Assalamualaikum warahmatullahi wabarakatuh. We are from Group 1 and now we will present about the determination of mercury concentration in body lotion using cold vapor atomic absorption spectroscopy, CVAAS. The group member of the Group 1 is Muhammad Arash Shahmi bin Khairul Hasri, Hoi Tenkian, Dania Alia Hamdan, Aino Fatrina binti Muhammad Nazri, and Farhan Hakim bin Khairul Anwar. So, for the introduction, this study investigates mercury levels in body lotions using cold vapor atomic absorption spectroscopy (CVAAS), a sensitive detection method. Despite regulations, mercury is still found in some lotions due to its skin lightening properties, posing health risks like kidney damage and neurological disorders. By analyzing commercial products, we assess compliance with safety standards and potential risks. The findings will aid consumers and regulators, emphasizing stricter enforcement to protect public health. Now we proceed to the objective. So, the first objective is to determine the concentration of mercury in products using cold vapor atomic absorption spectroscopy. Second objective is to assess whether the mercury levels in the tested body lotions comply with regulatory safety limits set by relevant authorities, such as the allowable limit of 1 mgl, 1 ppm. And the last objective is to raise awareness about the potential health risks associated with mercury in cosmetic products and emphasize the importance of strict quality control and regulation enforcement.
Hello everyone, I am Arash and I will be talking about the method selection. The method that we choose is CVAAS, which stands for cold vapor atomic absorption spectroscopy. So here are the reasons why we choose that method. The first one is high accuracy, second one is cost effective, third, widely accepted, fourth, moderate ease of use, and lastly, suitable for cosmetics. Here we have a table that can compare CVAAS with the other two methods, which are ICP-MS and SRF. So from this table, we can see that CVAAS is the best method because even the cost and ease of use is just moderate. It provides high accuracy and also fast. So CVAAS is the best method for this case study. So how does CVAAS works? CVAAS works by shining light through a sample where mercury atoms absorb energy. This energy change is measured to determine mercury concentration. To ensure accuracy, air, nitrogen or argon sweep the mercury vapor into the detector. The stainless ion helps convert mercury into its atomic form for analysis. Once the mercury passes through the detector, a short-term signal is captured, showing its presence. A closed system can produce a lower, steady-state signal. With its reliability and effectiveness, CVAAS remains a key technique for mercury analysis. Thank you, and I will pass to the next presenter.
In this case study, samples were collected from 22 products and 11 were chosen by random sampling. 3 products are branded while 8 are not, and 2 of the products does not have the permit from BPOM while the rest does. 10 parts per billion mercury metal ion stock solution were prepared and then diluted with distilled water to obtain solution with smaller concentration. In wet digestion process, the sample will dissolve in acidic solution to break down the organic matter so that the mercury can be easily measured. It is then heated and cooled for 3 times to get the average. The solution will then be analyzed using qualitative and quantitative analysis. In qualitative analysis, the solution was tested with sodium hydroxide to see the formation of precipitate. However, since the concentration is low, quantitative analysis is needed, in which a CVAAS was used. As a result from quantitative analysis, 3 products are positive for mercury, while the rest are below detection limit. A chemical equilibrium involved in this process is when the mercury ion reacts with the stannous ion, and then the mercury ion got reduced to elemental mercury.
Next, we use statistical tools to determine the accuracy test. So the tools we're using is the average of absorbance, the standard deviation, and also the relative standard deviation. The advocacy tests were conducted to show the level of closeness of the result of the analysis with the level of the result of the analysis divided by the actual level. So as you can see, the accuracy was really high. It's 99.33%. It's a good news that we met the requirement of the good advocacies. Next, we are using the linear test to find the correlation coefficient, the slope, and also the intercept. So for a linear test, it's helped to determine the relationship between the concentration and the absorbance using the standard Mercury solution. So the linear equation y equals to 0.087x plus 0.009. So with the correlation coefficient of 0.9726. So from the graph, we can see the higher the concentration, the greater the absorbance.
In conclusion, the concentration of mercury in body lotion from several brands was determined. The type of body lotion cosmetic containing mercury metal by using CVAAS method was determined. From total of 22 body lotion samples, 11 were selected by purposive sampling. The percentage error obtained was 0.37%, which was relatively small, while the accuracy value is 99.32%, which meets the requirements of a good accuracy.